Hi my dear friends, in today's class we are going to discuss about Boyce conormal form, multivalued dependency and fourth normal form, joint dependency and fifth normal form. Boyce conormal form BCNF. Application of the general definitions of 2NF and 3NF may identify additional redundancy caused by dependencies that violate one or more candidate keys. However, despite these additional constraints, dependencies can still exist that will cause redundancy to be present in 3NF relations. This weakness in 3NF resulted in the presentation of a stronger normal form called Boyce conormal form. Boyce conormal form BCNF or 3.5NF is a normal form used in database normalization. It is a slightly stronger version of the third normal form. BCNF was developed in 1974 by Raymond F. Boyce and Edgar F. Codd. Look at this example. Here we have a college enrollment table with columns student ID, subject and professor. In this table, one student can enroll for multiple subjects form. A student with student ID 101 has opted for subjects Java and C++. For each subject, a professor is assigned to the student, and there can be multiple professors teaching one subject like we have for Java. And student ID subject together form the primary key because using student ID and subject, we can find all the columns of the table. One professor teaches only one student, but one subject may have two different professors. Hence, there is a dependency between subject and professor here, where subject depend on professor name. This table satisfies the first normal form because all the values are atomic, column names are unique, and all the values stored in a particular column are of same domain. This table also satisfies the second normal form as there is no partial dependency and there is no transitive dependency, hence the table also satisfies the third normal form. But this table is not in Boyce conormal form, and while subject is a prime attribute, professor is a non-prime attribute which is not allowed by BCNF. To make this relation or table satisfying BCNF, we have to decompose it into two tables, that is student table and professor table. And these are the two tables, and now this relation satisfies Boyce conormal form. Next is multivalued dependency. If one or more independent relations are kept in a single relation, we can say multivalued dependency. A multivalued dependency always requires at least three attributes because it consists of at least two attributes that are dependent on a third. Next, we are going to discuss about fourth normal form. A relation will be in fourth normal form if it is in Boyce conormal form and has no multivalued dependency. For a dependency AB, if for a single value of A, multiple values of B exists, then the relation will be a multivalued dependency. Look at this example. Student. We are having student ID, course and hobby. The given student table is in 3NF, but the course and hobby are two independent entities. Hence, there is no relationship between course and hobby. The student table is student with student ID 21 contains two courses, computer and mathematics, and two hobbies, dancing and singing. So there is a multi-value dependency on a student ID which leads to unnecessary repetition of data. Next topic is joint dependency. If a table can be recreated by joining multiple tables and each of this table have a subset of the attributes of the table, then the table is in joint dependency. It is a generalization of multi-value dependency. A joint dependency JD can be said to exist if the join of R1 and R2 over Q is equal to the relation R. Then we can say that a joint dependency exists where R1 and R2 are the decomposition. R1 of P and Q and R2 of Q and S of a given relation R of PQS. R1 and R2 are a lossless decomposition of R. The examples are given. The relation have joint dependency, so they are not in 5NF. That would mean that a joint relation of the three relations is equal to our original relation employee. Next topic is fifth normal form. A relation is in fifth normal form if it is in 4NF and not contains any joint dependency, and joining should be lossless. 5NF is satisfied when all the tables are broken into as many tables as possible in order to avoid redundancy. 5NF is also known as project joint normal form PJNF. Look at this example. Here we are having three columns: subject, lecturer and semester. In this table, John takes both computer and mathematics class for semester 1, but he does not take maths class for semester 2. In this case, combination of all these fields required to identify a valid data. So to make the above table into 5NF, we can decompose it into three relations, that is P1, P2 and P3. That's all for today. Thank you.